We're continuing on with the numbers part of chemistry. Remember, each unit has the pretty part of chemistry and the numbers part. So we definitely have numbers part coming up here. Now, this way of working problems, you're going to have to buy into it. It's called the factor label method of working problems. It's a way of showing your work. And you have to work problems this way in order to get full credit in this class. So go ahead and buy into this now, all right? The factor label method, by the way, your textbook definitely emphasizes this way of working chemistry problems too. The factor label method relies on oftentimes what we call equivalency statements. And you know you have an equivalency statement if you have equal quantities on either side of an equal sign. So 1 inch, remember, is exactly equal to 2.54 centimeters. So that is from the English to the metric with regard to length, right? Now, it's exactly because it's by definition. If I just put DEFN, by definition. Now, down here, we've got another equivalency statement, again, between the English and the metric system. Now, this is an approximate relationship. 1 gallon is approximately equal to 3.785 liters. Finally, down here we have, with regard to mass, we have the English pound and its relationship to grams, metric grams. I kind of want to point this out, but so when it says 1 gallon is approximately equal to 3.785 liters, what they mean is exactly 1. That's exactly. If you have exactly 1 gallon, it's going to be equal to approximately. So this 1 is actually going to bring no uncertainty to our problems when you go around it. But this will bring uncertainty. And while I'm at it, remember that there's no uncertainty in exact numbers. So there's no uncertainty brought by either one of those numbers. So just kind of keep that in mind. Another relationship we've been talking about too, actually this one has an arrow, you need to memorize this, that with regard to volume, and these are both in the metric system, 1 milliliter is exactly equal to 1 centimeter cubed. So the factor label method can kind of be thought as kind of 3 legs to it. It's not necessarily steps, but it's 3 things to always think about. One is no naked numbers. Okay, no number without units, because the units are actually gonna are very important in the factor label method. The other thing is we are going to oftentimes take an equivalency statement. So I'll just say x is equal to y. Okay, I'm going to show you how this is, but from any equivalency statement we can come up with what we call 2 unit factors. I'll show you what they look like. There's a unit factor x over y, and there's a unit factor y over x. I'm going to try to convince you that if these are equal, then these ratios are both equal to 1. So that's what we call unit factors. Then the last thing or aspect of working problems using the factor label method is we are going to let units cancel. So at the first part of this semester I said, what if you have 7/3, okay, times 2/7 times 3/4, okay, and you were supposed to go ahead and come up with, you know, an answer. We could go ahead and put these fractions in our calculator, or we could recognize, and I kind of think of that divisor as being one kind of continuous divisor. We could recognize if a term is on the top, like the 7 is on the top and the bottom, it cancels. These 3's are on the top and the bottom, they cancel. And it looks like I can factor this into 2 times 2, so one of those 2's will cancel with that 2. My goodness gracious. So it boils down to 1/2. So that's what this last part is. Basically, we're trying to get the old units to cancel out and be left with the desired units. I'll kind of show you how that works.